Hello, this is John from caveofprogramming.com. In this tutorial, we're going to look at advanced conditions, let's say, in C++. We're almost to the point where we can start looking at loops, but there's one more thing I want to show you before we get there. So we've seen greater than, and we've seen less than, we've seen equals, we've seen not equals, but you can actually combine those conditions. So let's say int val1 equals, let's say 7, and int val2 equals 10. So imagine this is, this is something your program has calculated, or it's user input or something. And the stuff I'm about to show you, it works as well with strings and with doubles and with floating point, with the caveat that I mentioned in the last tutorial about being careful about comparing floating point numbers. Now we can write stuff like if val1 is less than 8, which it is, then cout, let's just put true, and endler else, let's have an else, so we'll say cout false. Okay, so if we run this, we expect to see, let's build it first. So project, build project, and run. So we expect to see true. We get true because val is less than 8. What if you want to take some action where you want to see if val1 is less than 8, and for example val2, you want it to be greater than 9 at the same time? This warning here, by the way, is just saying that I've got an unused variable because I haven't used this yet. And that's just a warning. The yellow icon won't stop your program compiling, but it's a warning that you will almost certainly want to pay attention to and clear up. The red icons are errors, compilation errors, and they mean your program can't even compile. So what we can do is we can use and here. So I can say and looks like this. It's a double ampersand. The reason it's double is because a single ampersand has a different meaning to do with a bitwise comparison that we may well get onto at some point in the future. So double ampersand and val2 is, let's say, greater than 9, or we could use equals or not equal or whatever. And let's run this, and it says true. So with an and like this, for this code to execute, the whole condition's got to be true. So val1 must be less than 8, and val2 must be greater than 9. Let's try something else here. So we can also use, for example, or. I'm just going to format that. So or looks like this. It's a double bar character. You must use a double because, again, the single one has a different meaning. And that's read as or. Let's actually put here 1 true and 1 false. Or we could use and. Let's say and true and false. And here we'll say or true and or false, just to distinguish them. So this is going to be true if either of these are true. So now, well, val1 is less than 8 and val2 is greater than 9. So this should execute. Let's just check it. So I run this and it says or is true. And let's try something else. So we can say and val2 is less than 7. So val2 is not less than 7. But this is still true because only one of these has to be true in order for the whole thing to be true. It's an or. So we're saying if val1 is less than 8 or val2 is greater than 7. Let's try that. So it's still true. But if they're both false, like val1 is less than 2, then in that case, of course, the or is going to be false. If val1 is less than 2, or val2 is greater than 7. Yeah, val2 is greater than 7. Let's make one of these, both of these false. So val1 greater than 2, less than 2. That's false. Val2 greater than 11, that's also false. So now it's going to be false. Okay, it's almost too much for my small brain, but you get the idea. If either one of these is true, then the or will be true, whereas for and, they've both got to be true. You must have this and this. Let's just set this back so that the or is true. Let's say val1 is, well, we can also use equals equals and not equals in here. Let's say, or if val1 is equal to 7, or val2 is greater than 11. So this is false now, but this bit's true. So the whole thing is going to be true. There we go. You can combine all the operators we've seen so far, the relational operators. You can use comparison operators. You can combine not equals and stuff like that. So you could say if val1, in fact, let's take a look at one we haven't seen before. If val1 is greater than or equal to 7. So we can use less than or equal to or greater than or equal to. These are also possibilities. And let's output, let's just use this, copy this, and format it. Yep, so it looks good. And we'll say, let's say greater than or equal to true, or greater than or equal to false. Let's run that and see how that looks. So there we go, it's true because val is greater than or equal to 7. It's actually equal to 7. Whereas if we just put greater than, we'd have false there because it's not greater than 7. It is actually 7. So we've got false. And greater than or equal to gives us true. Yeah, you can have fun there creating really complex conditions. You're not restricted to 2 clauses here. We could have another and here, or we could have an or. But it's really easy to create very confusing conditions. Well, let's take a simple example of that. Let's say we could say if val1 is not equal to, I don't know, 8, then we take some action here. Let's copy this. We take some action and we say it's true, otherwise we say it's false. This is something that you do see in code. I've seen plenty of this, but it's confusing because you have to think that extra bit. It's like if val is not equal to 8, else. Well, it's not so bad, but why not just switch these around? Say if it is equal to 8, so use a positive condition here, which is a little bit easier to evaluate mentally, and then switch the whatever code you have in here around. There's an art to writing conditions. You need to try to break them up into as the simplest form that you possibly can. Be very careful with using not equals in conditions. If you can use equals instead, then it's usually simpler, and you can create really horrible conditions, which again can be found in plenty of code. But as you make them more and more complicated, like if val1 is not equal to 7 and val2 is greater than 5, or val1 equals 6. You can see stuff like this sometimes in production code, but it's getting pretty revolting. This is going to evaluate from the left to the right, so it's going to say if val1 is not equal to 7, well that's already false. It is equal to 7, so that's going to be true, and val2 is greater than 5. That's also true. So this bit's all going to be true. So the whole condition is true. And let's just demo that. I'm not even 100% sure myself. No, I'm pretty sure, but let's run this and just check. So it says true. And that this condition would also be true if file1 was equal to 6, but all this was false, because we've got this or there. So it's either this bit's got to be true or that bit. But when you have a condition like this, it's getting ridiculous. You could find ways of writing this more simply, I'm sure. At least try to get rid of the not equals, or you can also use brackets to group stuff as well, which makes things, round brackets, it makes things easier to interpret. But always try to write your conditions in the simplest way possible. Think about switching the code in the if or the else bit, and replacing not equals with equals equals, if you see what I mean, if you can. So just be careful creating these crazy conditions. A lot of bugs in a lot of programs are caused by conditions that are hard to interpret and don't do what the programmer expects or what subsequent programmers who work on the code think it means. Okay, so there's one more thing I want to show you here, which is another trick that you can use to simplify complicated conditions, is store the conditions in booleans. So we could say here bool, I'm just going to call it con1 because it has no, this is just a demo program, so I can't give it a purposeful name because there's no purpose here other than demonstrating stuff. We could say con1 equals, single equals, and something like this. Let's use that. So at this point, when the program encounters this line, this condition will be evaluated and stored in there. And we can then say if cond1 cout condition1 is true, like that. Let's have a endler. Cout condition1 is false. And then if we run that, is condition 1, let's put the semicolon in, is it true or false? Well, val1 is less than 8, true. Val2 is greater than 9, also true. So this condition is true, and let's run that. And you can combine these booleans here, which sometimes makes for much simpler code than if you just wrote it all in the if. Let's say condu, cond2, condu. If cond2, let's make that equal to val2 is not equal to let's say 88. Okay, so this is now true, and we can say in here or cond2, and we run this and we expect this to be still true, because this is true if either condition 1 is true or condition 2 is true. And you can see that condition 1 is true, so the fact that condition is false doesn't matter, this is still true. So if you have a really complicated condition, sometimes splitting them up into Boolean variables like this first is going to help. Remember, a Boolean can be assigned to true or false, and this will evaluate, as will this, to either true or false. Okay, so if this is getting a bit too, I don't know, dry for your taste, don't worry about it too much. I wanted to show you this because we're going to be probably using this at some stage in the future, or you'll certainly encounter it if you do a lot of programming. It is worth practicing this. Try to make up some complex conditions. Just invent some of your own. And let's do a really quick summary here. I'm going to use the multi-line comment /star, and Eclipse has actually filled in the comment for me, the end of it, when I hit the return key. So conditions you can use equals equals. That's the simplest. Less than, greater than. We've got less than or equal to. We've got greater than or equal to. We've got not equal to, let's write this down, equal, less than, greater than, less than or equal, greater than or equal, not equal. And we've got things that we can use to combine conditions, like and we've also got or. Okay, so that's it for this tutorial. It's worth practicing that a little bit, but don't get too hung up on it, because your fluency with this will increase as you use it in actual programs that you try to write. And in the next tutorial, we're going to start looking at loops. So that's it for this tutorial, and until next time, happy coding.